Good evening again, everyone. So today we're going to see perceptual interfaces, which mean interfaces that can see its surroundings, not only have a camera, video camera, but can process that video camera and understand who is around, what the person is doing. So recognizing gestures, which involves hand tracking, face tracking, or body tracking. All these are included in perceptual interfaces. So before we start on this, a couple of announcements I'm going to make. So you must have received an email about the project presentations, which is this PDF I shared with you. We are going to meet at our regular scheduled time in the last day of classes this semester, which is about 3 weeks from now. Okay, so 3 weeks from now, you have 3 weeks until you prepare your final presentations. But as I said, these presentations may show the current progress of your project. I'm not expecting finished results. You will still have 2 weeks after these presentations, 2 weeks more until the end of the finals week to work on your final project reports, which may contain more results than you present in this presentation. Okay, but this is basically an opportunity to share with your classmates what you have done up to now, what kind of an interface you're planning to develop prototype for. And as you'll only have like 5 minutes, very short presentations. And therefore, I'm going to need you to send me your presentations beforehand by email, or I may maybe open up an OT-class assignment for this, okay? And then you may also submit your presentations there as an assignment. So we still have 3 weeks, but I will have an assignment set up on OT-class, for which the due date will be June 24. So you will send your presentations to me one day beforehand, and I will be showing the presentations on my screen, so we will not spend any time for screen switching and other stuff. Okay, so it will just be a very short presentation, as I said, 5 minutes. There are many projects this semester, and this is the tentative schedule. Some of the presentations may not start exactly at that time, so there may be short delays, or if you finish early, I mean, if you don't use the entire 5 minutes allocated for your project, that's fine. You may also do a 3-minute project presentation, that's also fine. But yeah, so these are just a tentative timing and order of presentations that we will have 3 weeks from now. Any questions about presentations? It will be in 1 week. Every group is going to present their presentations on June 25th starting at 7 p.m. All right, so I hope it's clear. And in terms of our plan, until the end of the semester, we only have 1 week of classes that I'm going to teach apart from today. So today we are going to talk about vision-based perceptual interfaces, and we are going to be left with 1 week of teaching. I will have 1 week to talk about ubiquitous computing and some future directions, and I will have this not next week, but I will give you 2 weeks for your reading assignment, which means that we're going to have our last lecture 1 week from 25th. So it will be 18th of June. So next week we're not going, this means that next week we're not going to have classes. So we're going to have that gap next week, and 11th of June there will be no classes, and I will make a post about this on OT-class in announcements, or as an announcement for this course. But just as a heads up, let me tell you, next week we're not going to have any classes. We will have our next class on June 18th, 1 week before the project presentations, and it will be, I will talk about ubiquitous computing, which means that you will have 2 weeks in your for your final reading assignment. Yeah, there won't be a quiz. That quiz will be 2 weeks from now. So that's the quiz next week, which will be about your last reading assignment. It will be when we meet on 18th of June. Okay, so 2 weeks from now, we will have our last quiz about the last reading assignment, which will be your uh, eighth reading assignment. So today it was the reading assignment number 7, which we're going to have. Quiz number 7 was for today, and reading assignment 8, I will post it right after class tonight, which is going to be, we'll have our quiz on June 18th. Okay, so 2 weeks from now. So is that clear? Which means that you will have 2 weeks for the reading assignment, and we will have our last lecture on the 18th of June. Since, as you can see, we are currently talking about week 12, 1 week ahead of we are 1 week ahead of schedule, and that's why we have 1 week to spare, and we are going to spare that week next week. There are no classes on June 11th. Our next class will be on June 18th with a quiz, with your last quiz, June 18th, and June 25th will be the project presentation week. So that's the plan until the end of the semester. I hope that's clear. If you have any questions, I will be happy to answer. Okay, so yeah, and quiz 7, which we're going to have tonight at 8, which is going to be available as usual at 8 p.m. Is already I already put that, but it will be open at 8 p.m. sharp, and again you will have 10 minutes to work on the quiz. So it's right at the close to the bottom of the page. So when you enter the class and get the class contents, week by week contents, it's right towards the end of the this page. Between in this week of May 31st, June 6th, I put quiz 7, which we will do today. Okay, tonight. And the other quiz will be in June 18th, and it will be here, along with your last reading assignment 8, which is, I think, a nice paper. It was a poster presentation in one conference. It's right at here. The number here you see here is not correct. It's actually reading 8. So towards a smart control room for crisis response using visual perception of users. It's a 12-year-old paper, but it appeared as a poster in this ISC RAM conference. It talks about a situation, emergency situation room, where users are tracked. How many users are there? Which users have authorities to do certain things? So when you talk about perceptual interfaces, we should not always think about a single person interface. A situation room like this will have many users simultaneously entering the room. So a perceptual interface will be able to track them all and act accordingly. So just when we talk about today perceptual interfaces, you should also have that in mind. We will no longer be talking about only just a single person with respect to a computer, but if the computers were able to see us in classrooms, in our offices, can we make use of this to make our interaction with them better? Okay, so that's the goal basically. We don't want you may say that, okay, I don't want the computers to see me with all the cameras around. Yeah, there are always privacy issues here, but in many other fields of human-computer interaction, in this case also, our goal is to make the usability of these technological devices better, to get a better interaction experience for users that use this. So perceptual interfaces, if we develop algorithms for tracking, for hand tracking, face tracking, or body tracking, will this help us to have more smarter offices, smarter homes, and smarter computers? That's basically the idea. So the slides that I'm going to use tonight are from, they're adapted from Matthew Turk's, and I actually took the human-computer interaction course from him. The reason I'm teaching human-computer interaction, if you wonder, this is not my research area. Is I found this course really interesting when I was a PhD student at the University of California, Santa Barbara. I took some graduate courses, and one of the courses I took was from Matthew Turk, this human-computer interaction course. I liked it a lot, and I liked the contents too. And when I came to ODTÜ, there was this course which was not offered by anybody before. The course was there, so I just said maybe I can give this course, and this is how I started giving this human-computer interaction course. Matthew Turk, if you don't know him, he was actually he was a faculty member at UCSD, but before that he was a researcher at Microsoft Research, and he's one of the authors of one of the most influential papers in 1990s, which was named Eigenfaces. If you know, if you have any interest in face tracking or anything, you must have heard this Eigenfaces idea. And Matthew Turk was one of the authors of the original Eigenfaces paper. So he was an expert in computer vision and face tracking. And this article, I mean, these slides on perceptual interfaces, I think George Robertson was Matthew Turk's colleague from Microsoft Research. And they also have an ACM magazine article issue about perceptual interfaces. So some of the material are borrowed from those. Okay. So why do we need perceptual interfaces, and how they can be part of multimodal interaction with humans interacting with technology, with devices that are around us? When, for example, it may be cars, it may be homes, it may be offices, or just desktop computers. Why do we need perceptual interfaces in such cases? Actually, there are many examples of such vision-based interfaces at our homes, especially in entertainment, in games. For example, PlayStation has these game. I mean, they track you with infrared cameras. The Kinect, for example, that we have read an article about this three-dimensional, the handlebar metaphor paper. It was also a perceptual interface. So any interface that has some vision-based tracking and understanding capability can be considered as a perceptual interface. So in general, these are in the area of vision-based interfaces, which uses some form of a camera. It may be a regular webcam, or it may be an infrared camera. It may be stereo camera to understand, to get depth of the objects around us, or it may be some kind of a radar-like camera, like a LiDAR, to get the depth information directly from a single camera. And I will talk about some examples. Some of these examples are old. As I said, this is an old. These slides are from a very old ACM magazine issue on perceptual interfaces, but there are still challenging problems in terms of body tracking, face tracking, hand tracking, and combining these different modalities. I mean, how can you combine? We have seen that put that there application last week when we were talking about speech. In the last slides in our speech-based interfaces, we talked about how we can combine speech with vision, put that there application. We don't have that smart interfaces yet, but the technology is there, and I think it's mature these days. Just like speech recognition and speech interfaces became now part of our everyday lives, I think vision-based interfaces can also be part of everyday lives. So here, Moore's law has driven computer technology for decades, which meant that every 2 years, the CPU speeds doubled, the memory got cheaper. So there was some exponential improvement in hardware. So in the last years, especially, I think there was also a big boost when GPUs came about, graphics processors unit, which then maybe also boosted the deep learning area with general purpose GPU programming, GPU. So there were some developments in hardware. But if you look at user interfaces, uh, I mean, when you have a desktop or when you have a mobile phone with touch screen, we are still, it didn't develop that fast. We are still using our keyboard and mouse when we're typing, or I mean when we're work in our office. The interfaces themselves, I mean, we don't use the our camera. For example, if you have a camera on your laptop or on your desktop, just I do, for example, you see me right now. We usually use this camera only for meetings like this, virtual meetings. I mean, it's not the camera itself or the microphone that comes with it is not part of my everyday interaction experience with my desktop. Okay, so when I come here, I still need to type a password to log in my desktop. Wouldn't it be nice, for example, if just I enter my office and I sit on my chair, immediately the computer recognizes it's me and saying, "Hello, Tolga, welcome to your office," and it automatically logs me onto my desktop. This doesn't happen. I mean, it's not. It's obviously this is possible. I mean, we have the technology for that, but it's not part of our everyday experience with these desktop devices yet. So if we were to use the cameras not only for these Zoom or WebEx meetings, they were if they were to be part of everyday interaction with our desktops or with our cars, then it means that these computers become they start perceiving. They become perceptual devices. They start seeing the environment. What happens, for example, I entered my office and sit in my chair, and the computer knows this as an event and responds accordingly. Or, for example, if somebody else sits in my chair and tries to do something, for example, hack into my computer, maybe when the computer sees that, say, okay, I'm calling the police, you should get out of this office as soon as possible, type of thing. You may use it as a security, but just putting some eyes on our computers may make it maybe a little bit scarier, but I believe there are many applications that can be that these such kind of an power can be used and when we are interacting with these devices. Okay, and not only vision, if they're also able to hear, for example, when I respond with speech, it responds back. So they become more and more uh, human-like, or I mean, they will have maybe some personality like your butler. But here, the main idea is not just to make them close to humans. The idea is to enhance our interaction, to make your interaction with your PC faster, enjoyable, more efficient. Just because they are there, just because the camera is there, I don't want to just chat with it or talk with it. I mean, I want my everyday experience with my desktop better. Okay, so the way perceptual interfaces are just one of the tools that may be used towards this goal. So here are some examples that this is the people have talked about this. I mean, the hardware is developing very fast, but the software cannot catch up in terms of interfaces. So this the difference between the developments in hardware, they're getting better and better, and software still interface is not being developed that much. I believe this delta especially is not there currently. We can write software that requires lots of resources. I mean, there are browsers that eat hundreds of megabytes of RAM, which we didn't have in 1990s probably. But we still I think software has a way to catch up with hardware all the time by consuming more and more resources. But here I think this delta is talking about the user interface itself remained fairly constant over time. The desktop interface. I mean, if somebody looks at this, the newest version of Windows or Linux, it's very similar to the desktop, the experience is very similar to the computers we had at the beginning of 2000s. Okay, so our experience did not change that much actually, but our computing capacity actually is increasing. And also there is another delta that is here. The human capacity is fairly constant. The lots of information can be computed or obtained by the computers, and the human capacity, on the other hand, if you look at human factors, it's remained fairly constant. Of course, we're also developing some new skills. We adapt. I think humans are best at adapting into their new environment. I mean, you cannot imagine. I mean, in just 10 or 15 years, I mean, these smartphones are now like one of our organs. It's like we're tied to them. So we can adapt to this new technology very fast. I think human capacity in that regard is also a little bit changing. I cannot say it's increasing all the time, but I can definitely say that it's changing. We do not remain constant. We adapt to different technologies around us. So here's a nice video about how sometimes interacting with a computer can be frustrating. This was, I think these videos, I don't know how they circulated back then, but these videos were like viral before YouTube. Okay, so before there was YouTube, and I don't remember how they were circulated and became viral. Somehow via the web or via emails. But yeah, obviously these videos were there before YouTube. So if you take a look at this video, it was a nice, funny video in which the guys get frustrated when working in office. I think this is just a sketch that is it's a scenario that like probably they're going to you get too frustrated with your computer, you may you may just throw it away. So yeah, as I said, this video was one of the viral videos when I think maybe 15 years ago, or maybe more than that. Let's get back to the slides. So the curse of delta may cause frustrations like this. So that was the purpose of this slide. And you look at evolution of user interfaces in 1950s, it was nothing basically. We had switches, punch cards. I mean, we don't even, there was no personal computers back then. Even in 1970s, it was just a server in which you could interact with a command line interface. That was the typewriter paradigm. And in 1980s, with the personal computers becoming available commercially, graphical user interfaces came about, and we had this desktop paradigm. And the desktop paradigm is still with us after so many years. So it was really a persistent paradigm. We still have the desktop paradigm where we arrange our folders, files like these. And I don't see a reason actually why we don't still. It's okay to have desktop paradigm after 40 years because we're comfortable with it. Maybe it's the most efficient paradigm to work with files or office documents, digital documents. That may be the best paradigm. Maybe keyboard and mouse are the most effective, efficient way to again work with documents, write programs, interact with a PC. But there's still the question of whether we have software and hardware improvements in speech recognition. So there is speech, there is vision-based interfaces. So we have seen all these different, there's this virtual reality, augmented reality coming about. So can we make maybe again, we should not just think about all these interactions from the perspective of a desktop computer. We are seeing new things here. like smart homes, uh, self-driving cars. So we have cars, homes, appliances at our homes, or when you go to, for example, a big conference room, a meeting room, for example, how do you interact with a meeting room in your company? Uh, every meeting room, probably, if you're going to meet in a meeting room, what are the functions a meeting room should provide? Scheduling, for example. There may be different groups, work groups that may need the same meeting room. So, meeting room is a shared workspace. What functionalities does it provide? Like, as I said, scheduling. Who is going to use the meeting room at what time? In many departments, this is still done by having a piece of paper put on the door of the meeting room and filling up slots that you want to meet. But sometimes even this may not solve the problem, because uh, sometimes we see clashes, schedule clashes, that two groups may want to use the same meeting room at the same time, or they wrote in a different time slot. Things like that may happen. But what other functionalities a meeting room has? Uh, a pres- uh, uh, an overhead projector, a PC, maybe a sound system. So how do you interact with these things? When you're a new person in a company, you have to learn how to use the projector, how to connect a new laptop to the projector, how to connect a existing desktop in the meeting room to the projector, switch between them, or maybe there are other technological presentation devices that are available in the meeting room. So obviously, using all these things, that's an interface, for example. That's human-computer interaction issues. There are such human-computer interaction issues even when you think about how you interact with a meeting room. You can think about similar things about how you interact with your smart home, how you interact with your automobile. And I think with the recent technological advances, uh, that obviously a desktop metaphor is not applicable when we interact with these new environments, when you interact with a conference room, meeting room, when you interact with a smart home, when you interact with an automobile. The desktop metaphor is no longer useful. But what kind of metaphor of paradigms are we going to have when we are going to interact with these intelligent devices around us? The Internet of Things, for example, how intelligent these things should be. But whatever it is, it will have to use some kind of an intelligent mechanism, intelligent interfaces, where one of those components may be a vision-based, a camera-based interface. And if you just take a look at your interaction with your desktop these days, you may think that it limits the human capabilities to some regard, because humans have two eyes, so we can see stereo, but our desktops are still flat 2D screens. There is limited audio. It's not three-dimensional, for example, or one hand tied behind back means that we don't use our gestures a lot when we're interacting with the desktop. There is limited tactile, touch-based interaction. Gestures are not there. No speech. We don't interact with our desktop with speech most of the time, but these are possible. I think in these years we have the technology has matured enough to be able to provide vision-based, speech-based, gesture-based interfaces. So what will be the next big thing in user interfaces? Immersive environments, getting into a completely digital world. Uh, I mean, this COVID 19 made us use these Zoom meetings, WebEx meetings a lot, but we're still in terms of presence, for example, different schools. I think some schools was it in Harvard or some in United States, in order to feel the same in-class feeling of teaching a class and for the students too. So right now everybody is listening to me. I mean, who is attending to this WebEx meeting? We have about 20 participants, including me. You're at your own environment. It doesn't feel like you're in class, right? for some students, this may be a big uh, disadvantage for motivation. So, can we use, for example, virtual reality to have presence in a classroom environment, even when you're not exactly in a class? Yeah, I think it was at Harvard. They had these multiple screens where each student is in a window. I mean, they have video, but they also like the videos are arranged like they're in a classroom. And so there you may have some special conference room which will allow such kind of things to happen. You may also remember some from if you have watched the NBA games when there were no people watching the games, when they were not allowed face to face, where there was not audience in NBA games. These days they do, but when they didn't have them, they had these again screens of people, the supporters, presented on projected on certain screens, and it gave a feeling to the players that some people are watching them. Okay, so immersive environments, wearable computers like smartwatches. I think the closest we get to wearable computers these days is to have these smartwatches or other devices with sensors that we can wear. 2 weeks from now, we're going to talk about ubiquitous computing. This was basically, it changed its name to Internet of Things these days. So it's like lots of computing devices that are connected, networked with each other, and they are invisible. They may be embedded in our surroundings, embedded in the car, embedded in our uh, home appliances, in TVs, in our workplaces, offices. So being invisible and around, and a lot of them around, maybe talking with each other in a network manner, uh, and is what is called ubiquitous computing. Ubiquitous means like it's everywhere and invisible. I think Internet of Things is more close to the concept of ubiquitous computing these days. There's also tangible user interfaces that you can physically interact with, coupling of physical objects with and digital data together, and multimodal user interfaces that use multiple information channels at the same time. And there's also the concept of affective computing, which means that it's like computing interfaces that have certain emotions, and also that interfaces that can understand emotion, understand whether the user is frustrated or not, and also show some emotion back. Especially with like humanoid robot like things, this affective computing may be a big issue. So these are some still ongoing research areas, and especially there are also things like when we have these ubiquitous computing, if all of the automobiles have some computing and networking ability, we may also use that to, for example, prevent accidents. If the automobiles were able to talk with each other without in the background, which means that by some networking technology, if you know the automobiles that are around you in, for example, 50-meter radius, you will be able to, for example, maybe avoid accidents, certain type of accidents, or this may also enhance the experience of self-driving cars if they they're they are aware of their environment and they're aware of themselves too. Okay, so yeah, here in 2000s, the idea was, I mean, we are now to 2020s, the perceptual user interfaces or PUI. The idea was to have a more natural interaction even with our desktops or our environments. So like smart homes, automobiles, more natural type of interaction. And the perceptual user interfaces, they were they had the potential to provide this. They still have the potential to provide such an interaction, because human to human interaction is multimodal. We use vision, we use gestures, we use speech. And so providing the same technology also in our interaction with devices will provide a more natural way of interaction. So that was the main goal of perceptual, of perceptual user interfaces. So here's how definition of a perceptual interface: highly interactive. Just like, for example, when I enter my office and sit in my chair, the computer waking up automatically, greeting me, logging me in automatically. So it means that it's highly interactive. For example, also when my phone rings, it automatically pauses the recording of this lecture video, maybe, or mute me automatically. Imagine, so when you have a phone call that interrupt you at a meeting, you have to go here, mute yourself, and then maybe stop the recording, pause the recording, and then you don't want to, because these to get into your recording. What if these things are all automatically done by the computer when it detects that you have a phone call that is coming? So from the microphone, and it also verifies that you're on the phone by using the camera. And after that, it takes the necessary actions that you would do by yourself seamlessly. So it's again highly interactive. It uses multiple information channels, audio, speech, and it may also give me feedback about what it's doing. So it may say, I'm muting your current meeting. The screen recording is now on pause, so it may also provide some feedback as to what it's doing at the moment. And these are the general definitions. They're highly interactive multimodal interfaces modeled after natural human-to-human interaction, and they're not just passive. These interfaces, for example, they're not always looking for input from the user. They are preemptive. They can when you just sit in your chair in your office, they automatically respond to this event that happens in the physical world, which means that they're always aware of their environments. They're not just passive. And multiple modalities means that they use multiple information channels simultaneously. It's just not just mouse, keyboard, or the monitor. And yeah, these are all the repetition of what I said. They're perceptive. They have human-like capabilities. What is the user saying? What is the meaning? Is this a command? Is the user searching for something on the web? Who is the user? So user authentication, identification is also possible with vision-based interfaces. Where is the user? Is the user's attention on this screen, or is the user's attention on something else, on the physical desktop? What is he doing? So all these things make the system perceptive. And multimodal, the idea of multimodal is to be able to do these things, use multiple information channels at the same time. And multimedia is the output provided by the computer to the user in different formats, in different media formats like text, graphics, audio, video. All of these together, it's called multimedia. And when the interaction becomes multimodal, it means it's using multiple information channels, and being aware of the user makes the interface, it makes the system perceptive. In order to respond appropriately to the surrounding, the system has to pay attention to the people. It may probably have a model of the room already, and when a certain person comes in, the system should be able to track that and should be able to understand the current context, whether currently I'm alone in my office, I'm not in a meeting, but if somebody comes, I may be in a meeting. Okay, or is this person in a meeting, or is this person just currently coding, doing some programming on the desktop, or surfing the web? So what is the current context? What the use in this user's task? And perceptual machine has to be aware of their environment, who is doing what this person is doing, when, where, and why. And they therefore intelligently they should be adaptive. So we have seen adaptive interfaces which has some intelligence in them, to adapt themselves automatically. So such perceptual interfaces, they should also be adaptive. They should adapt themselves to the overall situation and the individual user. So for your reading last reading assignment, the emergency situation room, you will see that the room is capable of watching multiple people and on understanding context. So how do these all these pieces fit in a perceptual user interface? We have multimodal input coming from the user, a perceptive user interface, the multimodal output, multimedia. All of this together is called perceptual user interface. So as I said, this was a special section on. I told ACM magazine, but actually the name of the complete name of the magazine is Communications of the ACM. There was a special section on perceptual user interfaces, which was about 2 decades ago. But still, it was really like a visionary article. We don't have all of those technologies realized, or applications realized even in these days. So, and in order to have these things realized, the technologies from different disciplines, algorithms, methods from different disciplines have to be integrated, from computer vision, from speech recognition, speech interfaces, from graphics and visualization, from robotics, maybe, if you are going to interact with a humanoid robot, for example, user modeling. Haptics is the area of touch-based interfaces, and also cognitive psychology. There's psychology, human, such as we cannot forget about the human factors. So cognition and psychology should also be taken into account. So here, natural human to human interaction is using multiple channels at the same time, and it should be something similar with a machine. Machine has to conduct all these technologies: user modeling, vision, speech, haptics, learning, graphics, tracking, to have a perceptual interface. And the main reason again behind all these, why do we use multiple information channels? In order to provide a more natural looking interface. The multimodal interface attempts to use all human communication skills, because human to human communication is multimodal. And it may be some of these modalities may be simultaneous or not. And how are we going to integrate these modalities is an important challenge. There are temporal constraints, like the time-based synchronization of these modalities is important. And there are different multiple styles of interaction for different applications, for different situations. You're not going to interact with your smart home as you interact with your desktop computer. And this was, and we have seen this put that there example last week. This was in the name of the application was Bolt in 1980s, in which speech and gestures were used simultaneously in this application, where you manipulate some digital markers on a map by pointing to them and speaking up a command. And today's interfaces fall far short of human capabilities. We are not using all of human capabilities in today's interfaces. A higher bandwidth is possible with different multiple modalities, and different modalities are good at different tasks. Speech is good for something, but using the keyboard may be good at some other thing. Okay, so making use of the good parts, the more efficient parts of each modality will make the execution of these tasks faster and more enjoyable. And when you use multiple information channels simultaneously, certain ambiguities may be resolved, errors may be reduced if you use both speech and, for example, vision together for speech recognition. Such errors may be reduced. And multimodal interfaces are more engaging, meaning that users are perceived doing multiple things at once. Users can do multiple things at once in this way. Here, again, this motivation, I'm going to skip this. Motivation is it's basically repeating different things. And how could we achieve perceptual interfaces, multimodal interfaces, develop and integrate various relevant technologies together, like speech recognition, speech synthesis? I think all these are, I can say, let me turn on annotate. This is done, this is done. We can do very good natural language processing, vision, recognition and tracking in computer vision, I think, is done too. We are very good at graphics, animation, and visualization. So we have all these technologies. I'm not an expert on haptic I/O, touch-based I/O, in which you also physically feel the buttons, for example, as physical objects. An example of an haptic interface was BMW's iDrive. I mean, I don't know if you're familiar with this. I'm not familiar. I haven't experienced myself, but what it has was it has this. Let's search for this on the web. So BMW iDrive. So it's still warning. So it's this. So this one is like a haptic interface, in which although it looks like a smooth surface, it's not entirely smooth. You can feel buttons if depending on a certain context. If the context menu changes, for example, you start feeling buttons underneath your hand at certain spots, and you can click on them. So at least the original one was like that. Maybe they have changed it later to something else. But the iDrive, it was the original one was a haptic interface. So iDrive had haptic feedback. Yeah, it was also in the CES 2017 BMW's haptic interface concept car. iDrive touch controller, touch and go, touch screen, haptic feedback gun. So actually in 2007, they maybe dropped that. Force feedback, iDrive force feedback. So you can take a look at this. But one example I can remember about haptic interfaces which allow you to feel physical force is this haptic is BMW's iDrive. They are also used in some CAD/CAM design tools. There are haptic interfaces in which you hold a pen like this, and depending on whether there's physical object that is behind virtually, uh, these haptic interfaces may make you feel some kind of a force in that direction. So this physical feeling of force, touch-based force, uh, is what we call haptic interfaces. So effective computing, I think we're also doing good progress there. Tangible interfaces, I think this is still not done. Interfaces that we can play with physically. We can, so if you search for this, interfaces, tangible interface. There are like, look at this sandbox. In which you just play with some physical sand, and based on that, a different projection is done here. So things that you play, you can physically interact with. And I think this is still under development. It's not a finished technology yet. Sound recognition generation, similar to speech, I think we have proceeded very well in these areas. User modeling also, there is good progress in this one too. And conversational interfaces has, with these new deep learning, especially with this GPT-3, we may have these conversational interfaces very well as commercial products, maybe in near future in everyday places. So conversational interfaces are also there. There has been developments in this area too. So detecting gesture, being aware of the user. I told this before when I was talking. So when the user is on the phone, the computer goes into some waiting mode. Or natural navigation. So when you're playing a first-person shooter game, to dodge the bullets or whatever these are, you may use your physical body to do that. And this is possible with VR headsets actually. When you are playing a virtual reality game with a VR headset, since there is the 6 degrees of freedom of your head is tracked, such things being in the game really makes you feel like you're using your whole body as a way to interact with the game. So that's a really good experience. It may be Quake too. Yeah, you're right. It looks like Quake. So, so I told you this before, right? I mean, I played Half-Life Alyx on a VR headset, and it's a really yeah, and the user interface at the bottom, the health bar, this I think this is Quake too. So I played the Half-Life Alyx with a VR virtual reality headset. It was really a remarkable experience. I mean, the first you enter the graphics are really good. You can just sit there just watching a completely new alien city to you, and when the shootouts with the bad guys feel really realistic because you can just really hide behind a column and they won't be able to see you, and this hiding action you're doing with your body, you can crouch, you can you can look behind the column that you're hiding. So all this makes the gaming experience, I think it gets it to a newer level. And this is done because just a simple 6 degree of freedom head tracking. By just tracking the head only, this is what we can do. Imagine we have really perceptual computer vision applications. Not only the head is tracked accurately, but the whole body, the hands, everything is tracked. For example, one thing I found in Half-Life Alyx, for example, bad was I sometimes find it very difficult to uh, change the clip, the magazine of the gun, because you have to do something like this. You have to do a gesture to get from a magazine from your backpack. But that wasn't understood all the time. I mean, because I think it was just using the hand controller to understand. Of course, it's, I mean, the only thing that it can use is the two controllers and the VR headset that you have on. So based on the gyroscope's capability of that controller, it will not. It's just understanding. I mean, maybe these two actions, that whether you're putting down the controller in its place or whether you're moving it, this, because it cannot be tracked. I mean, it can be tracked at a certain time, but if it gets behind the controller, for example, I think it may not have a very good accurate readout. But this is what I experienced anyway. It was really difficult to tell, okay, I'm reaching my backpack and grabbing a clip, and it was a difficult thing to do. So, but if there was something, a perception interface which tracked all of my movements very accurately, it will all these small hiccups would be solved. And there are many issues. If you have read or watched, for example, the book Ready Player One. The movie was not that good as the book. There, in terms of the perceptual interface or virtual reality type of interfaces, there are lots of things that could be done that will feel you that you're present in that current situation. So there are lots of research issues. What are the most appropriate and most useful input-output modalities for certain functions, certain tasks? Where should you use vision? Where should you use speech? Which one is good in which task? So this is still there are still some questions to be answered, and depending on different tasks. Is the event-based model appropriate? So, which means that, for example, when I come into my office, sit in my chair, detecting that as an event and responding according to that. Is this appropriate for every type of interaction? What is a perceptual event? A person sitting in a chair, a user raising his or her hand. So is there a useful, reliable subset of events that we can use? Well, there may be some non-deterministic events. For example, if instead of raising my hand fully, if I do something like this, is this going to be considered a raise of hand? How do you allocate your resources? Because if the desktop computer has to be active all the time, perceiving its environment all the time, how do you allocate your resources to doing these things, being active all the time? There are multiple goal management, multiple goals of the user. How do you manage them? Training, calibration of these things. There are environmental restriction. You cannot use all modalities everywhere. For example, if you're in a conference that you're listening to some speech, you cannot use the speech modality because you have to remain silent when when you're in the audience in a conference. So things like that. There's also always this privacy issues when the computers are aware of their environment all the time. This data could be hacked and could get into the hands of people with wrong goals, okay, bad goals. So this is privacy. Uh, Maintaining the privacy of all these data channels is really a critical thing to consider. And here is a cartoon about privacy. So these are two dogs behind the desktop. Probably, maybe there was no Twitter back then or Facebook, but if they know how to use a computer, they can be just regular users on Twitter or Facebook. On the internet, nobody knows you're a dog. So they're making advantage of this thing. So this is a cartoon about privacy that appeared in 1993. Look at this. It's like the internet was not that widely available for everybody in 1993. And there are also some people object to this perceptual user interfaces is not accepted as the way to go by all human-computer interaction specialists. There are certain arguments against intelligent, adaptive, agent-based, and interfaces that look like humans. Do we really need such interfaces that mimic human interaction? Do we want them to be intelligent, adaptive? And here, these objections, they tell that, okay, human-computer interaction will be efficient, and it should be characterized by direct manipulation. It should be the human who initiate the interaction, who is in control of the interaction. So these are objections raised against these intelligent or perceptual interfaces. When you have intelligent and perceptual interface, this intelligence, since it's doing some probabilistic decisions too, it will be non-deterministic. So, which means that sometimes you will not be able to predict what the computer is going to respond to how is the computer is going to respond in that situation. So it may not be very predictable. So some human computer interaction experts argue that efficient interfaces have to be deterministic and predictable, and direct manipulation is the key. And that's maybe they are saying that maybe desktop metaphor with keyboard and mouse is around for 40 years because it follows these characteristics. It's direct manipulation of your files, all the things you do when you're interacting with a desktop or with a PC, or their predictable interaction. And here it's the user who accomplishes these things. It's you that you move files from here to there. Okay, so giving the responsibility and sense of accomplishment to users is what makes interaction efficient. So these arguments are not, we cannot tell in every situation they will be correct, but still it may also make sense. So the objections against perceptual user interfaces, I think they also have some grounds of truth. So, and another thing is they say it won't never work because artificial intelligence is hard. That's another objection. But I think with deep learning these days, with neural networks, very highly developed, AI is not that hard anymore. In some tasks, they actually surpass human capacity. So there, this HAL is the computer from Space Odyssey, 2001 Space Odyssey. So is 50% of HAL will be good enough to have a conversational, intelligent perceptual interface. So, and that movie, if you watch this movie again, 2001 Space Odyssey, after you take this course, and just observe the computer HAL from the perspective of user interfaces, you're going to see that HAL has many interesting capabilities. Oh, by the way, thank you for a reminder, Tuana. So I'm going to give you 2 more minutes at the end of the quiz. So let's have it's quiz time. I will stop recording now.